Hello, my dear students. You are welcome to World School of Mathematics. Sudipsir.math here, discussing about basic calculus. This calculus is mainly for 11, 12, but this basic part can do any student of class 7, 8 also. So, I am discussing that basic or preliminary part of a calculus, especially this class for limit of a function. Okay. So, if any student of class 7, 8 also 9, 10 watch this video, the student can learn the basic concept of limit of a function. So, today's discussion is limit of a function. Limit of a function. Limit of a function. Okay. Today's discussion is limit of a function. Limit of a function. Limit of a function. Now, for this, we have to know about function. Function fx can any expression, maybe algebraic expression or trigonometric or logarithmic or exponential function. Okay. Now, say fx equal to 2x plus 3. This is simple algebraic function, linear equation. Now, for this we know if we put 1, if 1 equal to 2 into 1 plus 3, that is 2 plus 3, 5, etc. Okay. Now, say f of 2, then this will be 2 into 2 plus 3, that is 4 plus 3, 7. So, by this way, we can find the value of any real value of function, that is f1, f2, f3 or f of half, etc. Whatever required, we can easily find by using this. Now, this is a like straight line. Now, for x equal to 1, we will get one value. X equal to 2, we will get another value. X equal to 3, also we can get another value, etc. Now, another equation, say fx equal to x square minus 4 by x minus 2. Simply you will get all the values except x equal to 2. If you put x equal to 2, you will get 2 square minus 4 by 2 minus 2, that is 4 minus 4 by 0, 0 by 0. Now, this 0 by 0 is undefined. 0 by 0 is undefined. Something by 0 is also undefined. Now, 2. At 2, certain point where this is undefined. But we can get any value other than 2. We can get f1 equal to 1 square minus 4 by 1 minus 2, that is minus 3 by minus 1, that is 3. So at 1 we can get 3. Again at 3, that is 3 square minus 4 by 3 minus 2, 9 minus 4, that is 5. Now 3 also we can get 5. This height is 5, this is 3. Okay. Now what will be the approaching value of the function when x tends to 2? Just at x equal to 2, it is not defined. Just at x equal to 2, it is undefined. But we can get value very nearer to this, that is f of 1.9999 dot dot. Very nearer or approaching value we can get this, suppose 1.999 whole square minus 4, we can get 1.99, whatever it is, approaching to 2, approaches to 2 or tends to 2, minus 4 by 1.999 dot dot minus 2. So this will not 0, tends to 0 but not 0. So that value will be the approaching value or limiting value, not the exact value. Okay. So for that we will do another thing. First we will factorize this to reduce the equation and remove the 0 factor. Remove the 0 factor. So fx can be written x square minus 2 square by x minus 2. Now this will be x plus 2 into x minus 2 by x minus 2. Now we can remove this factor, and the condition is when x not equal to 2. If not equal to 2, it will not be a 0. That's why for limit x tends to 2, this will be x square minus 2 square by x minus 2, that is limit x minus 2, factorize this, x plus 2 into x minus 2 by x minus 2, cancel this and give the condition, since x tends to 2, x minus 2 tends to 0, x minus 2 not equal to 0, this is x tends to 2, that is x minus 2 tends to 0, x minus 2 not equal to 0. That's why we can cancel this. Now the function become limit x tends to 2, just x plus 2. So now put the value, that limiting value 2 plus 2. So your answer will be 4. Your answer will be 4. So at that time when x approaches to 2, this height will be 4. This will be value of y or fx will be 4. But it must be equal left hand limit and right hand limit. This is left hand approach. Left hand approach. Remember, left hand approach means limit x tends to, this is called tends to tends to or approaches to. This is called tends to or approaches to. Now x approaches to, tends to or approaches to 2. This means if x tends to 2 minus, that can be assume 1.9999 dot so on. So in this number line, this is if this is 2, this is left hand approach. Left hand approach very nearer to 2. And for right hand approach, x tends to 2 plus, this is right hand approach 2 plus. So this can be assumed x equal to 2.00001 and so on. Now, if these two approaching value are equal, then only the limit will exist. If not equal, then limit does not exist. Or if it is something by 0, limit does not exist. Okay. Now, suppose I am giving another example. Before that, you have to know one thing. Suppose mod x. What this signifies? Mod x. Now, mod x means suppose mod of 2, it will be 2, mod of minus 2, also 2. So, mod is absolute value of the function. Mod x is absolute value of the function. Okay. Now, mod of minus 3 will be 3, mod of 3 will be also 3. Now, these values are numerically known, but for variable mod x can be defined x when x greater than equal to 0. Okay. So mod x equal to x, mod x equal to x when x greater than equal to 0, and mod x equal to minus x when x less than 0. So mod x can be redefined this. Remember, mod x can be redefined this. Now, suppose you have to find, say, fx equal to mod x. Now, if you want to find f1, so you have to take this. 1 is greater than 0. 1 is greater than 0. You have to take this function. That's it. That is 1. Now, if you want to find mod x minus 2. Now minus 2 for this. Minus 2 is negative. You have to take this. That is minus of minus 2. That is 2. Again, if you want to find f2. 2 is positive. That's why you have to take this function. That is 2. Now if you want to find f of minus 3. You must take this function. Okay. That is minus of value of 3, that is 3. So mod is always positive, but for variable you have to break this function. If greater than 0, mod x is x. If less than 0, mod x is minus x. Okay. Now using this, suppose limit, you have to find limit x tends to 0 mod x. Now for this we have to check LHL and RHL. Remember, if LHL means limit x tends to a minus fx equal to limit x tends to a plus fx, that is LHL equal to RHL, then this value will be limit x tends to a fx. Then this value will be x tends to a fx. If LHL equal to RHL, then only the limit exists, and that will be the limiting value. That is limit x tends to a minus fx will be same as limit x tends to a plus fx. Then only it will be the limiting value at x equal to a. Now for this function, we will check LHL and RHL. Now, say mod x, fx is mod x, fx equal to mod x. Now this mod x can be written x when x greater than equal to 0 minus x when x less than 0. Okay. Now LHL limit x tends to 0 minus fx. So it will be limit x tends to 0 minus, in 0 minus fx will be this minus x. Now this will be minus of 0, that is 0. Now RHL will be limit x tends to 0 plus fx. Now for 0 plus, this will be 0 plus equal to limit x tends to 0 plus is x. Now put this value 0. Therefore LHL equal to RHL equal to 0. So the limiting value will be 0. Limiting value of this will be 0. If these two are not equal, limit does not exist. I am giving example. So LHL equal to RHL, this will be value. Therefore limit x tends to 0 fx or limit x tends to 0 mod x equal to 0. So this is the approaching value 0. Now function of mod x is like this. If x equal to greater than 0, then fx equal to x. This will be the graph of mod x, and approaching to 0, both are left hand approach and right hand approach will be 0. That's why limit exists. Again, giving another example, say limit mod x by x. You have to find mod x by x. Mod x by x. Now, if fx equal to mod x by x, then this will be x by x when x greater than equal to 0, and this will be minus x by x when x less than 0. When x less than 0. Now LHL and RHL. Now LHL, left hand limit. LHL limit x tends to 0 minus fx is mod x by x. Now for 0 minus mod x is minus x. So limit x tends to 0 minus x by x. So it will cancel limit x tends to 0 minus 1. That is left hand limit is minus 1. Now RHL limit mod x by x, limit x tends to 0 plus. Now for 0 plus, limit x tends to 0 plus, mod x is x. This is mod x equal to x by x. X by x. So that this will be limit x tends to 0 plus, this will be 1. So LHL is minus 1, RHL is 1. Therefore LHL left hand limit not equal to right hand limit. So limit does not exist. Limit does not exist. That is limit x tends to 0 mod x by x does not exist. Does not exist. This is does not exist. So what will be the graph for limit x tends to 0, 0 minus, this is 0 minus, this minus 1. Not touch here. This is minus 1 and for this plus 1. This is plus 1. So at x equal to 0, this is broken. At x equal to 0, this part is broken. That's why limit does not exist. At 0 plus, the value is 1 and 0 minus, value is minus 1. That's why limit does not exist. Okay. Now for simple function, just you have to put the value. Say limit x tends to 2 x square plus 3y x plus 2. You can just put the value. If after putting this value, this is not 0, denominator non-zero, then you have to put just the value. Okay, the limiting value will be 2 square plus 3 by 2 plus 2, that is 4 plus 3 is 7 by 4. So your limiting value will be like this. But if it is like another example, say if this is like limit x tends to 2, but this is x cube minus 8 by x minus 2. So if you put this 2 here, it will be 0 by 0 form and that will be undefined. If you put this, then it will be 0 by 0. Put this 2, 2 minus 2, 0, 8 minus 8, 0. So we have to remove that factor. We have to remove that factor which becomes 0. Now, for that, we have to simplify it. We have to simplify it. Limit x tends to 2. This is 2a cube minus b cube, x cube minus 2 cube by x minus 2. Then limit x tends to 2, a cube minus b cube means a minus b into a square plus ab plus b square by x minus 2. Now cancel this, and you have to give the note since x tends to 2, x minus 2 tends to 0, x minus 2 not equal to 0. This is not equal to 0, that's why we can cancel this. Okay, then your limit become x tends to 2, and this will be x square plus 2x plus 4. Now put the value, that is 2 square plus 2 into 2 plus 4. Just put the value 4 plus 4 plus 4. So this is 12. So the limiting value is 12 when x approaches to 2, the value of the function approaches to 12. It is not the actual value, it is limiting value. Okay, very nearer to this. So if after putting this you get 0, then we have to remove that factor, then only you can get the limiting value. Okay. Now for the limit we have to follow some properties. Suppose limit x tends to a, fx plus gx, two functions are there. Now you can separate it. Limit x tends to a, fx plus limit x tends to a, gx. You can separate it. Okay. You can separate it. Again, suppose limit x tends to a, if minus, then also you can separate by giving minus. Now if product fx into gx, then also you can separate it. Limit x tends to a, fx dot limit x tends to a, gx. You can separate it to get the value. Number 3, if divide limit x tends to a, fx by gx, then you can separate it. Limit x tends to a, fx by limit x tends to a, gx. This way you can separate it, okay, provided this is not equal to 0, provided limit x tends to a, gx not equal to 0, gx not equal to 0. This condition we must follow. If it is 0, we can't separate it. Okay. And any condition, any constant c, limit x tends to a, c into fx. So simply c can be taken outside, limit c into limit x tends to a, fx. Okay. And also suppose limit x tends to a, fx whole to the power n, fx whole to the power n, then this can be written limit x tends to a, fx whole n. So limit can be taken inside a power. So these are the basic properties we have to follow. These are the basic properties we have to follow for finding the limits. Okay, for finding the limits. And another thing, for this some standard limits are there. Standard limit means formula. Okay, some standard limits or formula. Standard limits, that is formulas of limits we have to follow. Simply limit x tends to a, simply limit x tends to a, x to the power n, just put here a to the power n. Okay. Number 2, limit x tends to a, x to the power n minus a to the power n by x minus a. By x minus a, this will be n a to the power n minus 1. This will be n into a to the power n minus 1, where n is rational number, where n is rational number. Remember it. Where n is any rational number. And similarly another formula, limit x tends to 0, 1 plus x whole to the power n minus 1 by x. 1 plus x whole to the power n minus 1 by x equal to n, where n is rational number. Set where n is rational number. N is rational number. Okay. So these are the algebraic limit standard values. Another thing for exponential. If limit x tends to 0, e to the power x minus 1 by x, it will be 1, where e is an irrational number, e equal to 1 plus 1 by factorial 1 plus 1 by factorial 2, 1 by factorial 3 plus dot dot up to infinity, and by sum of this e becomes like 2.718 dot dot. It is an irrational number. That is, e lies between 2 and 3. An approx value this, where these are the factorial. So 2 factorial, this can be written also 2 factorial, that is 2 into 1. Now n factorial or factorial of n, that can be written n minus 1, n minus 2, dot dot 3, 2, 1. So we will use this for permutation combination. So factorial 3 means 3, just giving idea, 2 into 1, that is 6, this is 2, etc. Okay. Now for e to the power x minus 1 by x, it will be standard limit 1. Okay. Now other formula, if other than e, say limit x tends to 0, a to the power x minus 1 by x, it will be log of a by c. It will be log of a by c, or directly you can write ln a, same as ln a. Now for this, here if it is e, then it will be 1. Okay. A is other than e. A is any number, 2, 3, 4, any number, any fraction. A is any real number. Where a is any real number, okay. So a to the power x minus 1 by x equal to log a by c, or ln of a. Now another is limit x tends to 0, log of 1 plus x by x, it will be 1. Standard limit for this, it will be 1. Okay. And this is also base e. This is base e. Okay. Now trigonometric limit x tends to 0, sin x by x equal to 1, and limit x tends to 0, only cos x, this will be 1. This will be 1. Another thing, if limit x tends to 0, 1 plus x whole to the power 1 by x, this will become e, and this part, if limit x tends to infinity, then 1 plus x tends to infinity, 1 plus 1 by x whole to the power x, that is infinite series, which will become the exponential part. Okay, and this will be also e. Now it is clear, when x tends to 0, then 1 by x tends to infinity. Now here x tends to 0, so power is infinity, 1 by x tends to infinity. And when x tends to infinity, when x tends to infinity, 1 by x tends to 0. Clear? X tends to infinity, this is 1 by x tends to 0. That's why both are e. Okay. And also you have to remember, if x tends to 0, 1 by x tends to infinity, and if x tends to infinity, 1 by x tends to 0. Okay. Now I am giving some example of using these limits. Okay. Suppose find the value of limit x tends to 2, x tends to 2, x cube minus 8 by x square plus x minus 6. Now check, if you put x equal to 2 here, then this is 4 plus 2 minus 6, 6 minus 6, 0. Now x minus 2 becomes 0. For due to this, x minus 2 tends to 0, that's why it becomes 0. Now to find this limit, we have to factorize it, then we can get cancel of this factor, then we must put the value. So the processing is, you have to factorize it. Primarily you have to factorize it. Limit x tends to 2. Now this will be x cube minus 2 cube by, now this is middle term. Do you know middle term? 6, 3 2 is 6. X square plus 3x minus 2x, just middle term. 3 into 2, 6, and 3x minus 2x equal to x. And this is a cube minus b cube. This is the formula of a cube minus b cube. Limit x tends to 2, that is x plus 2 into a cube minus b cube, that is x minus 2 into x square plus 2x plus 4. Okay. This is a cube minus b cube, that is a minus b into a square plus ab plus b square by x common x plus 3 minus 2 common x plus 3 x plus 3. Now limit x tends to 2, x minus 2 into x square plus 2x plus 4 by x plus 3 into x minus 2. Okay. Now this factor will cancel and you have to give the note, since x tends to 2, x minus 2 tends to 0, x minus 2 not equal to 0. That's why we can cancel it. If it is 0 by 0, we cannot cancel 0, 0. Okay, but x minus 2 tends to 2, 0. Because x tends to 2, we can assume 1.999, very nearer to 2. But x minus, in that case, x minus 2, that is 1.9999, whatever it is, this not equal to 0. This is left hand approach. But this value, just find this value, this not equal to 0. If you take right hand approach, that is 2 minus. If you take right hand approach, then it can assume 2.000001. Now in that case also x minus 2, in that case also x minus 2, that is 2.0001 minus 2, that not equal to 0. That case also this is not equal to 0. Now this part is not equal to 0. That's why we can cancel it. We can cancel it. Now your function become limit x tends to 2, that is x square plus 2x plus 4 by x plus 3. Now simply put the value of x equal to 2. Put the value x equal to 2. This will be 2 square plus 2 into 2 2 into 2 plus 4 by 2 plus 3, that is 4 plus 4 plus 4 by 5. So your answer is 12 by 5. This is 4 plus 4 plus 4, that is 12 by 5. So the limiting value of this function is 12 by 5. Clear? Giving another example. Example 2. Suppose trigonometric limit x tends to 0 sin 5x by sin 7x. So we know for this type, we know the standard formula is limit x tends to 0 sin x by x, and that value equal to 1. Okay. So our standard limit is sin x by x, limit x tends to 0, sin x by x equal to 1. So we have to modify this to get the limiting value. We have to modify that. So by using that properties, we can divide it. Limit x tends to 0 sin 5x by limit x tends to 0 sin 7x, and divide this by x and divide this by x. Okay, divide this by x. Since, give the note, since x tends to 0, x not equal to 0, that's why we can divide numerator and denominator by x. So it is cancelled. Sin 5x by x, sin 7x by x. Now you have to adjust that limit x tends to 0 sin 5x by 5x, because this must be same into 5, and when x tends to 0 you can write 5x tends to 0 also, and for the denominator also limit x tends to 0, check, this is sin 7x by x means you have to write 7x and into 7 to adjust this. You have to write into 7 to adjust this and 5 to adjust this, and when x tends to 0, 7x tends to 0. So give the note, since x tends to 0, multiply 5 on both the sides. So 5x tends to 0 and 7x tends to 0. Okay. Now if you take, let 5x equal to t, 7x equal to u, then when x tends to 0, t tends to 0 and u tends to 0. So this value will be 5x is t, limit t tends to 0 sin t by t. So this is our standard form, into 5, and denominator also limit u tends to 0 sin u by u. This is also standard limit into 7. That is, your answer will be, this is standard limit 1 into 5 by 1 into 7. That is 5 by 7. Now you can jump this part directly if you saw 5x tends to 0, sin 5x by 5x, directly this can be written 1 and this can be 1. So after this you can write, directly you can write 1 into 5 by 1 into 7, that is 5 by 7. Directly you can write this, but it will be better to understand if it is t, that is limit t tends to 0, sin t by t, this is 1, u tends to 0, sin u by u equal to 1, that's why it will be 5 by 7. Okay. Another example. See another example. Suppose it is given limit, find the value of limit x tends to 0 e to the power 5x minus 1 by log of 1 plus 3x basic. Now exponential and logarithmic. Now first we have to remember that standard formulas or standard limits. Number 1, standard limit was e to the power x minus 1 by x. If limit e to the power x minus 1 by x, limit x tends to 0, then this will be 1. Recall this, limit x tends to 0, log of 1 plus x by x equal to 1. So recall these two formulas, and we will apply this to the for the given problem. Okay. Limit x tends to 0, e to the power x minus 1 by x equal to 1, and limit x tends to 0, log of 1 plus x by x equal to 1. Now we will use this. So to get this, we have to modify that. First, we have to write limit x tends to 0. This is e to the power 5x minus 1 by x, and limit x tends to 0. This is log of 1 plus 3x by x. So we have to divide numerator and denominator by x to get the standard limit. To get the standard limit, we have to divide by x and give note since x tends to 0, x not equal to 0. That's why we can divide the numerator and denominator by x. Now for standard value, e to the power 5x by 5x is required. Now limit 5x tends to 0, e to the power 5x minus 1 by 5x into 5. So this becomes standard limit, and limit 3x tends to 0. Multiply both sides by 3. 3x tends to 0, log of 1 plus 3x by 3x, and for this adjustment 3 is required here. Now this is also standard limit. Now either you can assume t or u like this. This is t, this is u. Then e to the power t minus 1 by t, or log of 1 plus u by u, or you can direct use the formula just make sure that limit 5x tends to 0 e to the power 5x by 5x, and this is 3x tends to 0 1 plus log 3x by 3x. That's why you can put the standard limit 1 into 5. This is 1 into 3. So your answer will be 5 by 3. So check this. Standard limit of this will be 5 by 3, and this is for 5 and this is become 3. Okay. Now another example. Number 4. Number 4, another example. Limit x tends to 0. Limit x tends to 0. Limit x tends to 0. Root over of x square plus 9 minus 3 by x. Now it is clear. If you put x equal to 0, then this is 0 and this part is 0, means root 9 is 3, 3 minus 3. So this is the form of 0 by 0. Now we have to remove that part to get the limit. If you directly put here, you get this is 0 and numerator also 0, 0 by 0. Now for this type, we have to rationalize it. Limit x tends to 0. Now this is root of x square plus 9 minus 3. So we have to multiply with the conjugate part. If root a minus root b, we have to multiply with root a plus root b, and vice versa. If root a plus root b, we have to multiply with root a minus root b. This is root a minus root b type. So we have to multiply with positive this. Root a minus root b type. So this is, we have to multiply its conjugate, this denominator also. Okay. So this is cancelled, and rationalize, simplify it. Limit x tends to 0. This is a minus b into a plus b. You know a plus b into a minus b means a square minus b square. X square plus 9 whole square. A square minus b square. You know a minus b into a plus b equal to a square minus b square. That's why this is a square minus b square, and keep this same, x square plus 9 plus 3. Okay. Then this will be limit x tends to 0. X tends to 0. This will be x square plus 9 minus 9 by x into by x into root over of x square plus 9 plus 3 plus 9 plus 3. So limit also you can write this or LT also. You can write LT also, same thing. Say limit x tends to 0, this will be x square by x root over of x square plus 9 plus 3. Okay. Now 1x will be cancelled. Limit, you can say limit x tends to 0, cancel, that will be x by root over of x square plus 9 plus 3. Give the note since x tends to 0, x not equal to 0, so this will be the condition. Now if you put x equal to 0, denominator will give 3 plus 3 6, so you can get the value. So just put the value 0 by root over of 0 plus 9 plus 3, that is 0 by 3 plus 3, 0 by 6. So the limiting value will be 0. Limiting value will be 0. So for this limiting, we get limiting value is 0 by 6, that is 0. Clear? Now say if this equation like this, number 5, say if this equation same, limit x tends to 0, all are same, just x square. New sum is just this is x square. All are same. So we have to do everything same. Multiply with conjugate, and this is just x square. This is just x square. Okay. Now for this step also it will be same. This is just x square. Now here also this is just x square. Now this step is just x square. Now it totally cancel. This part is totally x square cancel, it will be 1. So numerator part will be 1. And you have to give note x tends to 0, x not equal to 0, that is x square not equal to 0. Now you will get, put the same value 0, this is 1 and this is 1, and your answer will be 1 by 6. Clear? If we modify this x by x square, that for the new sum, same, rationalize it, and finally x square will be cancelled here, x square cancel, so it will become 1, and denominator is same. Denominator is same. Okay. Denominator is same, that is root 9 means 3 plus 3, and this is 1 6. Okay. So this is another example. And if it is tends to, another example, if it is tends to infinity, say another example, tends to, suppose tends to infinity. Okay. Tends to infinity, say find the value limit x tends to infinity. X tends to infinity and it is say 6x square plus 2x minus 5 by 3x squared minus x plus 7. Now you have to find the limit like this: 6x squared plus 2x minus 5, 3x squared minus x plus 5. Now we can't put infinity. We can't put infinity, but we can use like this. Let x equal to 1 by t. X equal to 1 by t, that is t equal to 1 by x. When x tends to infinity, 1 by infinity large value, that is t tends to 0. That is t tends to 0. So if we take x equal to 1 by t, then when x tends to infinity, t tends to 0. Now put this value. Limit t tends to 0, 6 into 1 by t square plus 2 into 1 by t minus 5 by 3 into 1 by t square minus 1 by t plus 7. Okay, t square is LCM and then t square will cancel. Limit t tends to 0. For numerator, t square is the LCM. 6 plus 2t minus 5t square by t square, 3 minus t plus 7t square by t square. Now this t square cancel, since t tends to 0, t square tends to 0, t square not equal to 0. Now your limit become limit t tends to 0. This will be 6 plus 2t minus 5t square, and this is 3 minus t plus 7t square. Now you can easily put the value of t equal to 0. Now you can easily put the value of t equal to 0. So this will be 6 plus 0 minus 0 by 3 minus 0 plus 0. T equal to 0 means t square also 0. So this is answer 6 by 3, that is 2. So your answer is 2. Your answer is 2, 6 by 3. It is clear, when t equal to 0, t square also 0. T equal to 0 means t square also 0. That's why the limiting value becomes 2. Okay. Now another example. Another example, limit x tends to 1, limit x tends to 1, x to the power 4 plus 4x cube minus 5x square by x minus 1. You have to find the limit, this. So it is clear, if you put x equal to 1, this will be 1 minus 1, 0. and this is 4 plus 1, 4 plus 1, 5 minus 5, 0. So clearly it is 0 by 0 form. This is 0 by 0 form. So we have to remove that factor only, then you will get the limit. Okay. To remove that, you have to factorize the numerator. You have to factorize the numerator. Now for this, limit x tends to 1, take common x square, then this is x square plus 4x minus 5 by x minus 1. Now factorize it. Limit x tends to 1, just middle term, x square plus 5x minus x minus 5 by x minus 1. Limit x tends to 1, x square, take common x plus 5, and this is minus 1, that is x plus 5 by x minus 1. So limit x tends to 1, x square, this is common x plus 5 into x minus 1, x minus 1. Now cancel this factor. This is the 0 factor. So cancel, if you cancel this factor, give note. Since x tends to 1, x minus 1 tends to 0, x minus 1 not equal to 0. That's why we can cancel it. Since this is x tends to 1, now x minus 1 tends to 0, x minus 1 tends to 0, that's why x minus 1 tends to 0, that's why we can cancel x minus 1. Okay. Now simply the limit become x minus 1, x square, x plus 5. So just put the value 1 square, 1 plus 5, that is 6. So the limiting value become 6. For this, the limiting value become 6. Okay, become 6. Okay, another example. Say, find the value of limit x tends to 1, x square minus 1 by log of x base e. For this you have to find the limit. Now check, the standard limit for log was like this. Limit x tends to 0, log of 1 plus x by x equal to 1. So we have to get log of 1 plus x here for standard limit. Log of 1 plus x by x, or log of 1 plus x by x will be the 1. So to get this we have to modify this. Okay, check. To get this we have to modify this. How? limit x tends to 1. This is x plus 1 into x minus 1. Simply a square minus b square. You know, a square minus b square, a plus b into a minus b. Simply. And for this, we have to write this log of 1 plus x minus 1. Basic. Now x can be written 1 plus x minus 1. 1 plus x minus 1. So this is 1 cancel, that is x. Now we take, let x minus 1 equal to t. Let x minus 1 equal to t. That is x equal to t plus 1. X equal to t plus 1. And also when x tends to 1. When x tends to 1, put this 1. Value of x is 1. When x tends to 1, t tends to 0. So your new limit become limit t tends to 0. Limit t tends to 0. Now put the value of x. X is t plus 1. T plus 1 plus 1. Because the value of x is t plus 1 and plus 1. And this is t by log of 1 plus t. Basic. Okay. Now see another thing. This t can be written this. Now limit t tends to 0. This is t plus 2. And here log of 1 plus t base c by t and limit t tends to 0. You know 1 by of this, say 1 by of a by b, that can be written b by a and vice versa. So b by a can be written 1 by of this by this. Okay. Say this is t by this, that can be written 1 by this, and this will be here. So this part we can write this. We can write this. Okay. This is not required. Okay. Now we get the standard limit. Limit t tends to 0. Log of 1 plus t by t. So put the value 0 plus 2 by standard limit is 1, that is 2. So this is your answer 2. Okay. So it is basic discussion of limits, its formula required and basic process of standard limit, using standard limit and to process of getting the limiting value of any functions. Okay. Hope you understood well. Okay. Thank you.